Hello, everyone. Today we are going to talk about linear functions. So, linear functions are one of the foundational concepts of Algebra 1, and I'm so excited to be able to start talking about them. So, we have some vocab, a little graphic organizer to get us started, and it's going to be a good time. So, a linear function is an equation, right, or a function that can be written in the form y equals mx plus b. A linear equation is then defined by a constant rates of change, which is called the slope. So the y's are always changing by the same amount the whole time. So because of this constant rate of change, right, constantly going up or constantly going down, the graph of a linear function looks like a non-vertical line. And you've definitely talked about these in pre-algebra. So if some of that is starting to come back to you, that is why. All right, so look at this handy dandy graphic organizer I have here. So remember we said relations, right? They pair inputs with outputs. That's like the big overarching group. Then a subset of that, functions. They make sure that every input has exactly one output, or every x has one y, or it passes the vertical line test. And then functions, there's all kinds of different functions. We call them families, where all the functions in each family kind of look alike. They have similar characteristics. And so right now we're talking about linear functions, but throughout algebra, we're going to talk about all different kinds of functions. We're going to talk about quadratic functions and different polynomial functions. We're going to talk about different radical functions like square roots and cube roots. We're going to talk about exponential functions and logarithmic functions. We're going to talk about trigonometric functions. We're going to talk about rational functions. Good stuff, right? So there'll be all other like extra type squares or rectangles going on in here, different kinds of functions. Isn't that exciting? All right. So if a graph of a function is going to be a linear function, right, it's going to be a straight line. It's going to have a constant rate of change, right? So linear, right, means it's going to be a line, not vertical. Constant rate of change. So this first one up here, she's looking good, right? So we say yes, constant rates of change. Right, because you can see how it's going up and then over and then up and then over and up and then over and up and then over and up and then over the same amount. This first one is tricky, right? So if I kind of, oh, how do I do this with the kind of the washi tape here? If I kind of cover up this part of the graph and we just pretend there's that left-hand side, that's kind of looking like a line, all right? And if I just cover up this part of the line here, all right, that's kind of looking like a line too. But unfortunately, it's these two parts together, right? So it's not having that constant rate of change. So this guy is not a linear function. So we would say, no, not a constant rate of change. All right, and then last but not least, we have this guy here. There's some curves in there, definitely not, right? So we would say no, and then another way we can say this, it's not a right non-vertical straight line. Right, that's curvy. So how the y's are changing from x value to x value is different. So like, I don't know, from here to about, hold on, what's I doing? Scribble erase. So let's see, for example, let this one here at this value. So between here and here, I went up a little bit first, but then I went down 2. Okay, but then between here, between like this x value and like this next x value over here, I went up a whole bunch, right? So that is non-constant, right? It's a changing rate of change. Alrighty. So are the following equations of these functions here linear functions? So what we're looking at here, right, is has to be able to be written for y equals mx plus b. So no funny business going on, right? No roots, no exponents on x, none of that. So this first one has a square right there on x. So this one can't be. So this one is not linear. This is actually called quadratic function. We'll talk about those later in the year. And the highest power, right, the highest power on x, we'll learn what's called the degree, is greater than 1. All right, for the next one, it's kind of written funny, so we want to try to rearrange it and see if we can get it into that y equals mx plus b form. So I'm going to start by subtracting 2x from the side. All right, so then I'll have minus 3y is equal to minus 2x plus 3. Remember, the guys are not like terms. We can't combine them. All right, now I need to divide both sides by 3. Negative 3, actually. I'll end up with y is equal to positive 2/3, right? Because those negatives cancel out x, minus 1. Because 3 divided by negative 3 is negative 1. All right, so this looks like y equals mx plus b form. That means that this is linear, right? Because it can be written in, right, y equals mx plus b form. All right, and this last one here, it's got this root. Okay, so this one here, because of that root, we would say it is not linear because it's got that square root going on in there. Okay, x is under a radical symbol. Look at that, one more example. All right, so now we're going to look at a table. So the cool thing about a table is we're looking again for that constant rate of change. All right, so if my x's are all increasing by 1, so notice in my first 2 tables, they're 1, 2, 3, 4, 1, 2, 3, 4. In my third table, we go negative 3, negative 2, negative 1, 1. So those are evenly spaced, which is good. I want to look at the spacing of my y's. So from 0 to 3, how did I get there? Well, I added 3. 3 to 8, how did I get there? I added 5. From 8 to 15, I added 7. So because those aren't all the same number, right, I wasn't adding or subtracting by the same amount every time, this is non-linear because it has that non-constant rate of change. All right, that's the next one. From 1 to negative 1, I took away 2. From -1 to -3, again, I subtracted 2, and from -3 to -5, again, I subtracted 2. So because those were changing by the same amount, this guy here, he is non-linear. So this is it. Oh, I meant that is linear. Oh, man. Shouldn't be filming late at night. Alright, so that one is linear because it has that constant rate of change. I was just checking to see if you're paying attention. Right, and this last one, let's see what's going on here. So from -9 to -6, I've added 3. From -6 to -3, I added 3. From -3 to 0, I added 3. Alright, so this one is linear. That is a constant rate of change. Adding 3. All right, everyone, that's linear functions for you.